Single-layer PCBs and double-layer PCBs are two basic types of boards that have only one or two layers of conductive materials over the substrate. When more routing space or signal integrity is required, multi-layer PCBs are suited to meet these demands. Unlike single-layer and double-layer PCBs, multi-layer PCBs stack multiple layers of conductive and insulating materials to create a complex network of connections. The stack-up typically includes copper layers, cores, substrates, and prepreg.
Copper layers and substrates are familiar to most designers, but what about prepreg and core materials? Could you give us a further explanation?
Sure. Prepreg and core are two types of insulating materials or dielectric materials in PCBs. Prepreg, short for pre-impregnated, is a layer of fiberglass cloth impregnated with uncured epoxy resin but without any attached copper foil. In a PCB stack-up, prepreg serves as both an insulating layer and an adhesive layer. When constructing a PCB stack-up, the prepreg is placed between adjacent copper layers or between a copper layer and a core material. During the manufacturing process, high temperature and pressure cause the epoxy resin in the prepreg to flow and bond the layers together, resulting in a solid, rigid board.
Great! So we've learned that prepreg acts as both an insulator and an adhesive in a PCB stack-up. Then, what exactly does the core represent, and what role does it play?
The core of a PCB is the central layer of the board that provides mechanical support and rigidity. It typically consists of a laminate material made of thin layers of copper foil bonded to a rigid substrate material. The copper foil on the core can serve multiple purposes, such as providing a ground plane or a signal plane. In multi-layer PCBs, there can be multiple core layers, with prepreg layers between each core layer and the outer copper layers.
We know that in traditional multi-layer PCBs, the number of layers can be identified by counting the copper layers. But when it comes to HDI boards, is the structure similar, or are there any differences we should be aware of?
Compared to traditional PCB stackups that rely on through-hole vias to interconnect layers, HDI stackups utilize microvias, blind vias, and buried vias to achieve higher routing density and better electrical performance. The X plus N plus X structure is a common way to describe the HDI stackup configuration. Here, X represents the number of HDI layers with microvias, while N represents the number of core layers sandwiched between these HDI layers. Some common stack-up configurations include 1 plus N plus 1, 2 plus N plus 2, and 3 plus N plus 3. To further illustrate how the X plus N plus X structure is applied in practice, let's consider the example of a 1 plus 4 plus 1 stack-up configuration. In a 1 plus 4 plus 1 structure, there is one HDI layer with microvias at the top of the PCB, followed by 4 core layers with no microvias in between, and finally another HDI layer with microvias at the bottom of the PCB.
Proper stack-up design is crucial for improving signal integrity and reducing electromagnetic emissions. We hope this video has provided valuable insights into multi-layer PCB stack-up design.